was in Cameroon. We're going to be seeing that. Let me just move forward so that you understand what the hotspot is. So this is what happened. You have the magma coming in from depth here. Look at it. Okay? And it formed all these rocks that formed at the surface. Because the plate is moving, it is going to form in a straight line. They are going to be following each other like this. Do you understand? So the younger granites extend from Niger through Nigeria, such as the Jos Plateau, and towards Cameroon, are a belt of anorogenic. Anorogenic means they are not related to mountain building. They are not related to tectonism. Do you understand? That is why they are called anorogenic. We have orogenic associated with tectonism. Anorogenic not associated with any tectonism. Remember, we're looking at three types of associated volcanism. We looked at the divergence, the convergence, okay? Then we're now looking at the one that is not related to any type of volcanism. Tectonism, which is the hotspot. So it's called anorogenic, not related to mountain with the ring complexes. Rather than being formed by a single moving hotspot, geologists attribute those formations to a complex combination of mantle plumes, that is hotspot magma, interacting with ancient lithospheric structure. Ancient lithospheric structure is that as the mountain plume is coming up, because there are faults on the Earth's surface, this magma will easily find its way through those faults. That is why they are believed to form in a straight line in a particular area. Are we following?
Yes, ma'am.
So what happened is that you have this mantle, the magma coming up. As it is coming up, there's a kind of crustal melting. Remember, whenever magma is coming up, it melts the pre-existing rock. In every area, it must melt, so it thins the crust. The crust becomes thinner, and then it melts it sharp, and then it pushes its way continuously. As it's melting it, it will now be pushing its way because it has to make way for itself. So it is by melting the pre-existing rock that it is making way for itself to come out. And because it is very high temperature coming up from the mantle, it has enough heat that can retain and melt all the pre-existing rock. So generally they form what we call ring complexes. Ring in your, I think it's in 400 level. I think I'm the one that's going to be teaching you this. 500, no, 400 level. It's 400 level, Geology of Nigeria. I'm going to be teaching you how all these rock types form, all the different rock types in Nigeria, how they form. So it is believed that the faults that enabled this magma to come to the surface were formed during Pan-African orogeny. Remember, the Pan-African orogeny is the one that formed the older granites, right? That is why they are orogenic related. While this one, younger granites are anorogenic. They are not related to any orogeny. So we have two rock types, two major igneous activity or granitic activity that has occurred in Nigeria. One is the older granite, the other one is called the younger granite. The older granite is scattered almost all over Nigeria, but the younger granite is restricted, is localized, mainly in the Jos Plateau area. You all know where Jos is, and they are associated with some mineralization, like your tin, columbite, niobium, tantalum. They are rich in those kind of solid minerals. So we're going to be looking at I want to show you now how the movements occurred all the way from Niger. So you have, this is a map showing where it started in Niger. You can see these black rocks. Are you seeing it? Hello?
Yes, sir.
All right. You can see that it started all the way from the northern part of Africa up to Niger. Nigeria now formed. And then it entered Cameroon. And then now the hotspot is believed to be somewhere in the Atlantic Ocean, which means it is still producing rocks. but it is now beneath the water. It's under the water, so we cannot see it. Do you understand? So while we know that these rocks are related, it's because they are similar in their geochemistry. And when you do age dating, you find that the one that is in northern part of Niger is the oldest. It's formed around 480 to 400 million years ago. The one in Nigeria, associated with the younger granite, the age is 215 to 140 million years ago. Then when you go to Cameroon, look at this one in Cameroon, outside Nigeria. Look at the one in Nigeria. This is the younger granite in the Jos Plateau area. You have all the way in the northern part of Africa, in Niger, in Nigeria. This is the Nigerian map showing the one in the Jos Plateau. You can see how scattered it is. You can see it's like a straight line. Do you understand? Even in Nigeria, it's like a straight line because as the plate is moving on the hotspots, the magma is being emplaced onto the earth surface, forming lava, which crystallized into rocks. So when you go to the Jos area, you're going to see those rocks now. They are called younger granite. I told you it extends up to, because when I was doing my master's, I saw some of them in Nasarawa, which have not been recorded. When we went to, I think in 2016 or so, some of our students went to Kogi. There's one part of Kogi that we saw some of them somewhere around here, and even up to Abuja, you can see it. Then it stopped because the plates moved. The next outburst was in Cameroon. Do you understand? So they are all related, all the way from the northern part of Africa coming down. It shows you that the plate is moving. Who can tell me the direction of the plate movement? If it started here and it's coming down all the way here, where is the direction of the African plate?
From north to south.
No, you have to use this direction now from is it moving towards the west or towards the east now? Is it pushing towards the west or towards the east?
Towards
It is
the west.
West one.
It is moving backward this way. Remember, there's the Atlantic Ocean here. South American plate is here going this way. African plate is here going this way, right? So we are moving this way, which means we left the old one, the plate moved away, it came here, the second one, the plate moved backward again, another one now formed. Do you understand? The plate moved away. The spot is stagnant. Look at the spot. But it is this plate that is moving away from the spot. Do you understand? Are you following? Are you following? This is where the spot is right now. And this is the oldest rock that formed. Well, that's not your problem. Direction is not your problem, but you understand what hotspot is right now, right?
Yes, sir.
And you can explain how they form. Can you explain how they form with examples? All right. So we're supposed to be going into Wilson cycle. That's your next topic, Wilson cycle. And before Wilson cycle, you've done seafloor spreading, remember before. But because it's related to Wilson cycle, I wanted to reintroduce it again before going to Wilson cycle. But I'm not doing that this week. So I want us to, somebody should tell me have you been listening to the news lately?
Yes, ma'am.
So who can tell me what is happening in Venezuela?
Earthquake, ma'am.
All right. Who can tell me what caused the earthquake? Fast, fast, fast. Once you delay, I know you are Googling.
It was caused by the crust. The continental distance, drifting of the crust.
By what?
How do I even put it?
By what? Hurry up. Who is talking? Nobody knows how
Caused
how
by
the
a shallow
It was
fault.
caused by divergence plate movement. Abi convergence plate movement, rather.
not really. No. Who else wants to try?
But it was caused by like a shallow strike slip fault.
You said
A shallow strike slip.
more like a strike slip fault, right? Then what kind of boundary is that one? Huh? Transform plate boundary. Good. So who else can give it a try? What caused the Venezuela earthquake? Now we know it's formed by movement of two plates sliding past each other. So who can tell me the plates, which of the two plates and what caused it and in which area? You don't know. Huh?
Is it the Caribbean and South American place?
Okay. After Googling, Ole, I caught you. All right, now let me show it to you. I think I have it somewhere, right? I know I quickly put something. Okay, yeah, on this plate. So the Caribbean and the South American plates. Remember, this area is around the ring of fire. Remember, right? I explained what ring of fire is to you. Where I said is an area on the earth where you have a lot of plate activities. This is one of them. I told you that that is where you find most of the earthquakes occurring on the earth. Remember ring of fire, do you?
Yes.
All right, we did that, I think, last upper week. We didn't meet last week. So last upper week, we did ring of fire where we looked at the different kinds of plate movement. You have you have divergent plates, you have convergent plates, you have transform all around that area. It forms like a different kinds of plate movement are occurring there. So this particular one too is associated with the ring of fire. It is around there. You have this Caribbean plate. Look at it here. And the South American plate. Okay. They are all active plate boundary here. So the Caribbean plate shifts towards the east, relative to towards the east, relative to the South American plate, which shifts to the west. Okay. So because they are moving in opposite direction, like our transform strike slip, you have a kind of motion whereby you have two plates grinding past each other. And when two of them are passing each other like that, what happens? You have serious tension being created, okay? And this tension keep gathering over thousands and thousands of years. Eventually, it gives way because let's give an example. Two of us are stronger. We are pushing each other. We are pushing each other. You are pushing me, I'm pushing you. We are passing each other, trying to pass each other. Initially, one of us will not fall, but eventually there's going to be a kind of release of tension and one of us will fall, okay? Or one of us will slide past each other. So that is exactly what is happening. Let me try to explain it in the easiest way I can. So the motion there is generally more like a strike slip kind of fault, and the movement here, this sliding interaction, it leads to serious buildup of stress. It is the release of that stress that generates this large earthquake in these areas. Do you understand? Hello?
Yes, ma'am.
All right. So if I ask you to explain the Venezuela earthquake using geologic map, can you do it? You can do it. Okay, then. I just want you to have good understanding of what you have a question. Do you have a question?
No, ma'am.
All right, then. I think we are done for this. So I don't know, should we start the second class today or we leave it? I don't know what time is the Muslim people going for prayer. Class rep. Should we meet after the prayers for the second class? Or you
Yes,
want
ma'am.
it now?
Ma, we can meet after the prayers. Most people are offline currently.
All right then. So let's will convey your class rep will convey the time to you because he has to get back to me now what time is convenient for you people. So thank
Okay,
you
ma'am.
all for coming. But you understand today's class very well, right?
Yes,
So
ma'am.
if I ask you to explain how the back arc basin formed, all the volcanic arc formed, all the trench formed, you can do that very well. If I ask you any question about what else did I show today? The Venezuela earthquake, you should be able to explain it for me. If I ask you about the hotspots, and you should relate it to the younger granites, or you should explain how the hotspots form, you should have good understanding. Is that okay? So you can explain all that, right? With diagrams.
Yes.
Hello?
Man, no with diagram. We would have to go back and read it.
And now I'm saying normally after my class, remember I asked you if you understand, and I try to remind you of what you've done, and I asked you, if I ask you about so and so, can you explain? I just want to be sure you understand. Of course, you will go back and read it. I'll give you your notes. I don't know if I should give you PowerPoints. I'm still thinking. Most of you, I said you people should be screenshotting. Because if I give PowerPoint, students don't read. That's why I hardly
We're
give
going to read
PowerPoint.
it.
So if you've been screenshotting, that means you have almost all the information at your hand. So if you can be able to explain what a back arc basin is, you should be able to explain what a volcanic arc is. You should be able to explain what a trench is, what a hotspot is. You should be all those things we did today. And I said to cap it all, you should be able to explain what happened in Venezuela that caused the earthquake. Can you do that? That's what I want to know if you understand today's lectures. That's all. You can draw them. There are simple drawings online you can check. You just draw the subducting plate, the overriding plate. You make your V, which is your trench. This is your trench. This one is subducting. You have your magma. You do small magma coming up to the surface. You draw your volcano with smoke on top of it. This is a volcanic arc. You come to the back. You draw a trench. These two plates trying to separate from each other. You draw your back arc basin. Okay? You can go and look for simple diagrams online on how to explain all this. Is that okay?
Yes, ma'am.
All right, thanks for coming. Look at this one, it's a very simple diagram that explains it. You can see this one shows the volcanic arc. It shows the trench. It's the back arc that it did not show. So you can use simple diagrams to explain what you're trying to explain. Hotspot, very simple to explain. Look at it. Magma coming to the earth surface. We can use this one with plates overriding. You have your hotspot, deeper mantle, plate tectonics at the top. You have chains of volcano at the top. So they are all simple. You can get simple diagrams online on all the topics. Even the previous topic we've done on convergence, divergence, transform. Go look for simpler diagrams that you can use to explain. You cannot, in geology, you get marks for your diagrams. I keep explaining that to you guys. Every diagram you add, you get marks. Sometimes you may not get your explanation right because of English. We're not English. We're not from England or US. So we have limitation. Sometimes if some students write, I find it difficult to even understand what they are saying. I struggle. But if I say that you have a good diagram to explain, I know you have the understanding, but it's English that is limiting you. Do you understand?
Yes.
Hello?
Yes, ma. Yes.
All right, thank you. So class rep, please get back to me. Let's decide. If people want the class today, if you want it tomorrow, I'm always available. Is that okay? All right, thanks for coming.
Sorry, ma, please, when we get this